Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL course on building energy systems and auditing. So, today we will start the module number 4, a new module. The module number 4, the 5 lectures will be on energy conservation building code ECBC, and at the very beginning we will start with the envelope performance factor. So, in this particular lecture we will give a brief overview of this ECBC code, and also we will discuss about how to compute a envelope performance factor for a building. So, this particular code, that energy conservation building code, was first established in 2007 to provide and to establish the minimum standard for building performance from the energy point of view. So, from today's modern need of the society, from the sustainability point of view, it is a one of the important step ahead. This particular code has some area of focus, and after 2007, the 2017 this code is revised. In the 2017 code, a provision of minimum energy efficiency standard of the design and construction was mentioned. It was mentioned earlier also, 2007 code also. It also introduced a daylight requirement of the building and also the shading. We will discuss that daylight part in this particular module itself, latter part. Maybe in the last 2 lectures will be on the daylight. It also talk about the renewable energy systems, which we will discuss in our lecture at the fag end of our course. It encourages the retrofitting of the building. We will discuss also the retrofitting of the building in some of the lectures in the maybe in the 7th or the 8th week, and it lead to the near zero energy building, which is not completely zero energy, but near zero energy building. One important thing is that this particular code or this particular method of whatever it has suggested in that code was applied to a new commercial building. This particular ECBC 2017 is basically for the commercial buildings other than the residential building. Residential building, we have another code, Eco Nivas Samhita. So, that also we will discuss in the next. So, for any new commercial building which has a connected load of 100 kilowatt or more, or the connected demand is 120 kilovolt ampere or more. So, for those little large scale of building, this particular code is, or these particular provisions are applicable. So, what are the purpose of this particular energy conservation code? It is a code of practice. So, it has some rules, it has some provisions, it has some alternative to take. In that particular alternative, choose an alternative from the designer perspective or so. Finally, it is focusing to the energy, and it also gives some kind of it also sets some kind of the standard, and also there are some kind of the enhanced level of energy efficiency. So, it depends upon the users that which the level of the energy efficiency they will try to achieve through their building design, and of course, there are some the minimum requirement also benchmarking. This particular code or these provisions are applied to building envelope, because building envelope we are discussing since last 3 weeks, that it is a envelope that actually interact with the outside, the environment. So, that envelope, the heat gain or the heat loss, whatever is actually through the envelope. So, it is discuss about the building envelope. It discuss about the mechanical systems, equipment and all those kind of a thing, which is also necessary for the running the building. It includes the air conditioning systems, it includes the hot water supply systems and all. Interior and exterior lighting, that is artificial lighting, is also included in this particular code, and the power motors, electrical power motors, the renewable energy systems are also included. So, basically we have discussed all the things, the theories of all the things. We have discussed the envelope theories of the heat gain, we discussed the mechanical systems including the HVAC, air conditionings and service systems and all. We also discussed the interior lighting systems, electrical power motor systems also in our second week lecture. Yes, renewable energy systems we have not discussed yet. So, we will discuss it definitely in the latter part. We will today discuss about this the building performance of the ECBC. In this ECBC code, as I told just little earlier, that it has included all type of building except I think 2 type of building, one is residential and one is the industrial building. These 2 are not included. So, it included the hospitality, that means this is 5-star, 4-star hotels. It includes the educational building, college, the universities, institutions and all, the healthcare building, the hospital, the shopping complex, the business houses like the offices and all large and small scale offices, or also it includes the assembly building like theatre and multiplex and all. In this particular code, they have prescribed 2 type of method, and after this 2 type of method, you need to simulate or calculate, and then you have to see that what is the actual performance of your proposed building. So, first method is called the prospective method, where it is a easy method. It is a method that you can compute by your own with the help of Excel sheet or maybe hand computations and all. This particular method includes the building envelope trade-off method, that is that particular trade-off method. So, it is the envelope trade-off method. So, envelope, in that envelope there are lot of surfaces, there are roof surfaces, there are wall surfaces, there are glazings and the windows and all. So, we can trade off, you can increase some portion, we can decrease some portion, and we can change the values of the materials and all. So, that is a kind of a trade off. So, by virtue of that building trade off method, they are actually proposing a particular factor called EPF or envelope performance factor. So, how your envelope is going to perform in future? See, the building has not yet constructed, it has been designed by architect, and based on that architectural design, how it will going to perform, that indication will give by this prospective method if we go through this envelope performance factor. And you have to submit, suppose in some kind of a project and all, you have to submit this EPF report and this building the envelope trade off report. The second method, that is the whole building performance method, in that we can use some software and we can estimate the annual estimated energy. That is a straightforward thing, just you do some kind of the software simulation and find out what is the total annual load. But when you start any kind of a design, and sometimes that design may change, or there may be some there is a kind of you have not sure that whether your design will be selected or not. So, in that particular stage, a whole building performance is not very much required, because it required time. Once the design is finalized, once you got the particular job, then probably the whole building simulation and performance method is fine. But if it is, you have 2-3 alternatives. choices. If you have just to bidding process, you are just bidding for a particular the design. So, in that particular scenario, the prospective method holds good. It is easy, less time taking, and it can do done in house, because the simulation and standard software simulation, you have to actually employ somebody, or you have to actually go to your consultant. So, they will charge you and all. This particular efficiency or this performance level in ECBC code, in 2017 code, they called, there are 3 such standard level or performance level. The first one is called ECBC building. I have highlighted in the blue color, ECBC building. So, if our building can achieve that particular typical EPF point, so I may say that this building is a ECBC building, which actually going to reduce, the energy consumption of that particular building may be reduced by 25% with respect to the typical building where you have not taken any kind of ECBC consideration. You can go further more, you can lift your design strategies or the ECBC standard little more strict way, and then you may achieve a ECBC plus standard. So, this first one is just ECBC, second one is the ECBC plus, and if you can achieve that ECBC plus, you may say that it will going to save almost about 35% of the energy with compared to the typical building. And the third level is super ECBC, that is furthermore very well guided and very strict ways of doing the things. There is no such the options available maybe, but if you can achieve that particular ECBC, super ECBC point or whatever, then we may say that this building is wonderful from the energy consumption and the conservation point of view, and it will be almost like 50% less with compared to a normal or typical building. So, we will see this ECBC, ECBC plus and super ECBC classification criteria in the next lecture. So, let us first discuss about the building envelope trade-off method. Based on this method, we have to find out this EPF, that is the envelope performance factor. So, first of all, it is the performance of the envelope, and in the envelope mostly it has 3 things. As you know, it is having some kind of wall system, opaque wall system, it has transparent glazings and the fenestrations, which has a ratio called WWR, window to wall ratio. So, this particular envelope trade-off method or this EPF factor computation is not suitable or should not be used where the WWR is more than 40%. That means, if a building is fully glazed or mostly glazed, so the amount of glazing is much higher, around 50-60% or maybe 80% some of the cases of his buildings. This particular method is not suitable for that or shall not be used for that. And there are no other alternative method prescribed as of now, the buildings which is having WWR more than 40% by ECBC. Probably in the future they may come up with some kind of guidelines. So, as we all know, this envelope is the prime the boundary where through where this heat gain and all these things are happening. So, ECBC provide a particular calculation ways to find out a factor, and we can compare your 2-3 alternatives or 2-3 architects they were bidding. So, whose performance was better based on this particular number or this particular factor, which is called the EPF. So, if you see a envelope performance factor, if you want to elaborately, you will see the mathematical formulas, but if you actually see, there is a design development. In the design development, what happened? We actually do some kind of the compact design, compactness. We see the how much compact is your design. So, you see the envelope surface area, how much is the envelope surface area. So, those are all numbers. Envelope surface area is a number. How much is the volume of your building? So, that is also a number. What is the building orientation? That may not be a number, but at least you may say that the longer side in the east, west or the south, north directions or so. So, there may be some kind of a 3-4 choices over there. The amount of fenestration, that means WWR and whatever, and also the amount, how much areas of the fenestration. The types of shading device, it's a long hanging device or the overhang or whatever, fins and all those kind of things. So, those are all design development. A designer, the architectural design, we do that. We design the building, compact building, much more surface areas, volumetric expansion, building orientations and all those kind, amount of fenestration, everything is design development. The second step, what we can do after the design development is done, we can actually put our choice of material, envelope material. So, what should be the wall material? Should be normal brick or fly ash or SEC blocks, or maybe a normal bricks with the cavity walls. So, there are a lot of choices, or normal brickwork or the fly ash brickwork with some kind of insulations also. So, there are a lot of choices. What could be my roof material? What could be my window material? Is it a double glazed or single glazed window, or it may be a very reflective kind of a window, or maybe it is maybe a normal kind of a 1 leaf 6 mm glass or whatever. So, finally, the U value and SHGC will come into the picture, and then that will be going to devise some kind of the heat gain formulas or heat gain phenomena or so. The design development and the envelope material choice, and third one is definitely the climate, because where is this particular building is located? Is it in this 5 climatic zone that India probably has this 5 climatic, probably not probably, India is the 5 climatic zone, prominent 5 climatic zone. So, where is your building is located, and also some of the other things which is required for the climatic data of the particular area. So, latitude data or the orientation also comes in some way or other. So, in this particular out of these 3 baskets, the first 2 basket is the architectural design plus properties of envelope material selected for the building is required, and the second one is your location, latitude, climatic zone is required. So, that fulfill our all the design process, right. At least the envelope portions may not be the working the functional portion of the building, but the envelope portion of the building. I am not interested probably as of now what is your functional requirement and how your building will going to function and all, and the fire exit, all those things. No, it is all the envelope of the building and the location specific and the material specific. So, in the design development stage, we can find out the roof area, we can find out the wall area, we can find out the window area, and window area also you have to find out separately how much is the north window area fenestration, how much is the south fenestration, east and west. We can also think of how much, what will be the U value of the roof material, what will be the U value of the wall material, what should be the SHGC and the U value of the fenestration materials in the all 4 directions and all. And also from the climate data, this code will help me. This first 2, if I say that the first one, calculate as per your architectural drawing. Your architectural drawing is ready, so you can calculate the roof, wall, window area. This you can obtain from the material specification mentioned in the BOQ and all these drawings and all. What is the material brick? So, you know its U value, take that one. This climatic data are the C factors, C factors, capital C. It for roof you have to collect or select some kind of C factor from the ACBC code as per the building type and the climatic zone. You have to, for wall you have to collect the C factor for the wall for different climatic zone and the building type, and also for the C factor for fenestration. There are 2 C factor for the fenestration, one is directly linked with the U value and one is directly linked with the SHGC. So, these are the code C factors are mentioned. See, there are 5 such tables are there. So, this table, the first table is probably for some climatic zone that was probably cropped. The second one you see, it is written as a hot and dry climatic zone or so. So, this is for temperate climatic zone, this is for cold climatic zone, this is for hot and humid. So, this is definitely for the composite climatic zone. So, those are the C factor, we will see that how that will be taken into account. So, finally, what are the steps involving in this EPF? So, what we have to do is that we have to find out the EPF of the roof, EPF of the wall and EPF of the fenestration, and we will arithmetically add those 3 and finally find out the what is the total EPF of my building. Now, in that EPF of the roof will be calculated as the, you have to multiply 3 things. One is the U of roof, A of roof, the area and the U value of the roof, and the C of the roof, the C factor that has to be taken from the code. U value is your choice, A is your area. So, that you have to calculate from your design and you have to put the material that whatever. And if you have, why this summation sign is there? Summation sign is for nothing. If you have your roof is have 3-4 portions and different materials, so you can add those. Similarly, you can find out the EPF of the wall, that U of wall and the A of wall multiplying by the C of wall, mass and other wall. So, mostly we go with the mass wall, because mostly we go for the mass wall. This is for the other type of wall is the curtain wall. So, mostly we will not take that one. So, the C of the mass wall, that again will be taken from the code. Now, this is a big equation is for the EPF of the fenestration. So, if I go back, this 2 take care of EPF of the roof, this will take care of the EPF of the wall. Now, the fenestration is taken care of by this equation. Big equation, look very big, but it is a very rhythmic equation. It has 4 lines. The first line is for the north fenestration, second is for the south, east and west. So, I told you earlier that you have to calculate the area of the north windows, south windows, east and west separately, not like the wall area, roof area you have to calculate whole. There is no need to calculate the east wall area, the west wall area, but here you have to calculate the different direction. And the first part, which is C1 part, first part of all are actually the U into A, that is U value of the, because you know the window take care of both the conduction heat gain and also the radiation heat gain through the SHGC. So, U of the wall multiplied by the A of the wall of the and the corresponding C factor of the, and A of the area of the window and the SHGC of the window and corresponding C2 factor. C1 factor is for the U values and C2 factor is for the SHGC, right. And there is the ACF, ACF is your a multiplier which is because of the shading and all, that is called the equivalent shading factor, shading equivalent factor. So, we will discuss how to calculate the shading equivalent factor in the next lecture or maybe next to next lecture. So, for each calculations, let me see that how can I calculate. So, suppose there is a building whose dimension is 50 meter by 25 meter by 8 meter, north south oriented, 20% WWR, it has the U value of roof, wall and windows are given, SHGC of the window is also given, and thirdly we need the data of the climate. So, it is a daytime building, building is a daytime office building, this run for 12 hours only morning, and look at it in the hot dry climatic zone of India above 15 degree north latitude. So, the first line gives me the design development sense, that it is a what is the building areas and all these things, window areas and all. The second line gives me the envelope material choices, and the third line gives me the climatic data. So, based on that I have to calculate the EPF of this building. So, first what I did, I first find out all the facade area, and based on the WWR, I have WWR is constant 20%. So, based on that I have found out the window area, all the 4 side window area and the wall area. So, this bold digits are required for my final calculation. I required whole roof area for my calculation, I required whole wall area. I do not require individual wall area, I require only the whole wall area, but I require individual window area for my calculation. So, this is that particular from the code. If I just go back a little bit, this is the, you have to take the proper climatic zone data. So, my climatic zone is hot and dry. So, I have to take this particular table number 4.17 table. So, in that table I have cropped that one, and this is the particular table. So, you see I have first found out the roof, the EPF of the roof. So, there are three things. One is the area of the roof, which is 1250 multiplied by the U of the roof 2.5, which is given in my problem, and the C of the roof is your 14.82 I have taken from this. Now, why I have taken from this, why not 21.12? Because this is a daytime business building. It is not a 24 hours building, hospitality, healthcare or whatever, no. It is a daytime building, office building. So, I have to take that particular part, this particular part of the table, right. This second part is for the 24 hours building table also. So, this one. Next, so then this is the EPF of the roof, 46,000 something. EPF of the wall, I know 960 is the wall area, 1.5 is the U value, and 6.4 is this mass wall. I have taken the mass wall because this is mass wall is mostly used for the cases, and I have only one type of the wall type. So, I do not have summation. So, that is invalid for me. So, finally, 9216 is the EPF of the roof of the wall, sorry. Now, I have to go to the fenestration. In the fenestration, you see, this is that big formula what we are discussing about. Now, this is the C factor of U corresponding to U. So, that means the C1 is associated with U, all the four sides. So, minus 0.37 is the U factor C value of north window. So, the C1 for the north window should be minus 0.37. Minus 1.35 is for the south window. So, minus 0.85 is for the east and minus 0.8 is for the west, and these are the purple color one big values are the C factor for SHGC, which is absolutely absent in case of the walls, because SHGC is 0 or there is no concept of SHGC in the wall or opaque. So, for the north, C2s are for the SHGC, because C2 belongs to SHGC part of the equation. So, 101 is for north, 252 is for south, 219 is for east and 226 is for the west. So, you just has to carry this number from the appropriate hot and dry climate zone, appropriate daytime or 24 hours building or so, and now I have calculated. So, those numbers I have taken. I know the U value is of the windows are 0.75, SHGC is 0.3, and these are this minus values, minus 0.37 whatever we have just now discussed, and this 101 this is for the U and this is for the SHGC. So, this is the U value 0.75, and 80 is the area of the north window, 80 is the area of the south window, 40 is the area of the east and 40 is the west, and all are multiplied by 0.75, which is the U value, common U value, and those negative numbers are the C factor, C1 factor for all the four sides. Multiply that, you will get the number plus the second part. Second part is what? This first, this is 0.3 is the SHGC, you see this 0.3 is the SHGC is for same, and this 80 and 40 are the areas, and this 101, 252, 219 are those corresponding C2 factor associated with the SHGC for all, multiply them and add them. So, minus 22.2 plus 2439.84. So, it becomes 2417. So, this is all the 4 and add it up. So, total EPF of the fenestration is 13,714.5. So, I got the EPF of the fenestration. The equation may look very clumsy, but it is a very rhythmic equation. If you understand this equation once, then probably you can just do it by calculation by virtue of the Excel sheet or so. So, these are the I should have shown it before. This is the areas of the windows or so which is cropped, and then this is the total EPF. I have the EPF has calculated for roof, wall and fenestration. So, 69,243 is my EPF proposed EPF of my building, and these are the 3. Out of that, you see the EPF of the roof is very high, 46,000 something, which is almost 67% of the total EPF value. Wall is less, 13%, which is 9,216, and EPF of the fenestration is 20% or so. For at least my this calculation, based on my architectural design, surface areas and all, based on my WWR of 20%, based on my chosen materials or so, my proposed EPF of this building is 69,243. It may be good, it may be bad, or maybe worst or very good, I do not know, but that we have to see with the EPF, ECBC or ECBC plus or super ECBC criteria in the next lecture. So, what we understand or what we do here at this particular time, we have just understand the Energy Building Conservation Code practices, recommendations, some of the recommendation of course, a brief outline, and also we have just completed to see that how a simple calculation for just like a small building of course, but how this particular equation actually takes care of the envelope performance factor EPF. Thank you very much.